Hey everyone, how's it going? Welcome to the channel. So today's video is all about copy-variants. Now if you don't know what copy-variants is, there's actually a teaser on the channel for this node. Go check it out. It's a pretty cool node and a pretty cool teaser, if I may say so. I've been working on this tool for a couple of months now. It took a while to just make sure everything is working and figure out the UI. There were some obviously some issues with it, which I've been trying to resolve, and I think it's finally in a stage where I'm happy with it, and I wanted to release it. If you want to download it, just go to this link. It's going to be available in the description. It's going to take you to my gumroad page. This is a free HDA, so you don't need to pay, but if you can, I would appreciate it. You can put down whatever amount in here. You can put down $10, $5, even $1, and that would be very appreciated. But if you can't, that's also okay. Just put down 0 in here and download the tool. And you can come back whenever, if you like the tool, just come back and donate a small amount of money. And if you don't want to do it, that's still fine. Just enjoy the tool. So what this tool does is essentially helping you with the copying task. Now, obviously we have copy to points, and inside this tool at the end, that is what we're using. But copying variants can be actually not the best process, let's say, because there are a bunch of stuff that you need to set up, and they're kind of unnecessary. Like it can be easier. It should be easier to do this kind of stuff. So this tool is not doing anything magical. It's just everything is ready for you the way they should be. So you just wire your inputs and just let the tool take care of everything. Before we move on to actually talk about the tool and me showing you how it works, a couple of shout outs. David Torno, he helped me quite a lot with the development. He helped me fix a bunch of bugs. It wouldn't have been possible without his help. Henry Foster, aka Toadstorm, the developer of MOPS. I took his course on Houdini School, and it was quite helpful. In fact, the tool was copy-variants version 1.0 until last week, but last week I decided to make some substantial changes in the tool. I rewrote a bunch of different stuff, and all of that was because I took Henry's course, and I figured out, I realized that some of the stuff were actually not wired correctly. So I changed a bunch of stuff, and the tool is now working much better. And Rich Nosworthy, if you don't know him, he actually made the Houdini in Bloom course, which you've probably seen images of that course online. Let me see, should have it in my recent searches. This image is actually pretty famous now. You can see it everywhere. It's a really amazing just course and a process. I loved watching that course, and his approach for working with Redshift proxies is great. I'm actually using the same approach, so shout out to him. It's amazing. And also my girlfriend Elnaz for designing the tool's icon. We're gonna see that in a moment. And Nima Abelghosemi for creating the soundtrack for the teaser. Nima is a very talented musician. Go check him out on Spotify. He has awesome music. All right, let's move on to the actual tutorial. All right, so let's jump into Houdini and talk about the basics of copy variants. So I've prepared a very simple scene. We have a bunch of different objects in here. I've added normals to them, add vertex normals, nothing too complex. This one also has normals. I believe these ones come with normal by default, so we don't need to do that. We're using a merge packed node, which will essentially pack everything. Every stream will be packed as one object, so you can have like multiple objects in here, just merge them together and just merge it down to this merge pack, and they will all be just considered one object. These are our objects. Everything fits in a 1x1 box, except the tube. So let me just actually push this one to 1. There we go. And I have a bunch of other stuff in here. So I have this sphere, which later on I will be using as a mask. And also I have this grid, which I generated the density attribute on it. I added a mountain sub, so I get this look, and it's also animated. Perfect. I'm just gonna uncheck density because I don't need to see it. I'm gonna place down copy variance. By default, copy variance has 4 inputs. We're gonna be working with the first one, the third one, and the last one. The second one is just kind of like a preset, so it doesn't really matter right now. Wire the geometry, it's going to require the target as well, and this is what we get. Now notice that some parts are actually empty. This is exactly what density is doing. If there's no density, the tool will just automatically assume the density is 1 everywhere, and if you have the attribute density, now the tool will set it to essentially what you're having in here. So it does matter what you set up on the surface level. Okay. If we go to copy variance, there are quite a bunch of options in here. So scrolling from the top, you have some global settings. These are for the inputs. Then you have global stuff. We're gonna pretty much ignore everything in here. The only one that we care about is the 4th option in here, object mask. If we enable it, the tool will give us an error because we don't have anything associated with the 3rd input. When we wire it, now you actually see the difference. So without object mask, with object mask. So this is our target. This is where I have this mask. Essentially what happens in here is that you are excluding this area from your density. And you also get this option in here, this tab for mask. You could actually invert it if you want and it will go crazy. You could play with it. Probably even make it like bigger if you want, and it will affect everything in the scene. That's pretty much everything we're going to talk about right now. The curve input is just importing a line in here, get some interesting like preset looks from it. We're going to talk about it later on. Doesn't really matter right now. Let's go to the point tab. In the scatter section, under points, you could actually obviously set the number. You could change the seed. You could relax them, you could uncheck the relaxation, everything works in here. If your surface is animated, you play it, you're gonna see them sticking to the surface. It's because this option is on. If you uncheck it, they're just gonna go crazy, as you can see. You could also change the frame that they're gonna stick to. So now that it's set to 240, if I merge them together, it is using essentially the frame 240 for the placement. If I come in here, go at the end, this is what's using the tool and placing them and then just bringing it back. As you can see, going through them, you get different results. They will still stick to the surface no matter what you set in here. It's just the initial position. And also, if you have any attributes associated in here that are changing, it's a good idea to just pick something that you like, because if your attribute is changing in here, then you can't have stick to the surface because it will be transferred down. Okay, you can go to the variance tab, just figure out how you want your objects to be associated in here. As you can see, the tool automatically is generating the distribution for us. You don't need to figure out the variant attribute. You don't need to check anything. Everything is just being generated by default. You could offset them. You could create a patch. This is the attribute from pieces node. It's just exposed up here. So internally, it's just using a default Houdini node for us. But it's using the rest attribute as the location. So now as we're playing them, they're not freaking out. Especially in the patches section and in the noise section, this becomes quite important, because if I switch this to the default P, well, right now, since we're doing the interpolation, it still doesn't matter. But by default, if you're working with copy to points and you set it up with the P attribute, the tool will freak out. The normal workflow, you'll get errors because a noise is actually moving around. We're using rest, but even if you're not using rest, the tool will take care of this for you internally. We have a randomized method in here, which you could use piece weights and just autofill them. And when you play with these values, you're going to get more or less of your objects. You have your seed. You can offset them. I don't think offset works with random. I think offset only works with cycle and probably patches. Yeah. And you could also just use a different seed for generating these. I'm just going to leave it at cycle. Just go to Pscale. We're going to ignore these two options. I'm going to create more in-depth tutorials later, which we're going to use to actually set up a scene from scratch. But right now, this is just a simple intro tutorial, so we're going to ignore everything. As you can see, by default, we have the attribute float adjust node in here as well. So it's working with Pscale. We can't actually visualize it in here because we're seeing the outcome at the output, but there are ways to do that actually in the visualizer tab, which we're going to talk about very soon. But you could influence this ramp. You could create your own stuff. This is set to random. You can use like a noise, for example. All these kind of stuff that you have, you could use like a piece, I don't know, like a curve view or something in here, like a noise to adjust value. It's the default attribute float adjust node exposed in here. You can go to orientation. You could but by default, we're using up and forward as our axis. It's set to normals for the up vector now. So your up vector is following the normals. In fact, if I go to the visualizer tab, visualize attributes, set it to point, and I don't need to see the surface. I just want to work with these. So visualize N and visualize up. So these are what we're seeing. Now, ignore N for the time being. Let's just focus on up. On the points tab, orientation, it's set to normals. Now, notice here, up is equal to the normal. If you set it to direction, it's actually pointing up. You could change this to whatever degree that you like, whatever direction that you like. You will also still blend it with the incoming normals. Again, we're setting the up vector in here, but we're setting it equal to be normal or a blend between the direction and the normal. So you get to like play with these, and it's actually pretty cool. I'm just gonna leave it at the direction for the time being. Let's talk about the normals. So our normals are actually pointing forwards to the Z direction now. This is the correct way everything should be set up for copy to points. If you remember from our talk about copy to points, we actually used to rotate stuff 90 degrees in order to, in the Z direction, in order to actually be facing in the normal direction, the normal way we're setting it up. So for example, if I have a box in here, I'm just going to use the same target in here. So let's just visualize it. We have 20 points in here, so let's just gather this, and I'm gonna add normals in here as well. Okay, so let's bring it down to maybe like 100 and float adjust. As you can see, like we used to do this kind of thing all the time, but it takes some time, and also it just freaks out when you play it, but we're gonna ignore that one. So when you scale the Y direction in this method, the old method, it's actually freaking out scaling it in the Z direction when you copy it. So the way we used to fix that was with the transform node, and you needed to transform this pointing towards the Z direction, and it would fix it. You either had to do this, or you needed to set up a sort of attribute in here to actually dictate that one, which is not easy. You need to say, hey, this is my attribute. I want up to be equal to normal, and now I want to define a new essentially direction. So let's just in here say sign up. I'm just gonna give them numbers, so I'm not gonna actually follow. I'm gonna hard code this. So up will be 0 1 0, and we actually don't need this normal now. And at sign n will be 0 0 1. So this is how you could fix it to be in this direction. And if you don't want to do that, just say @n in here, and it will follow the surface. But it's kind of weird. You need to set it up. It takes some time to do this, and as you can see, it's just not stable. But this is much easier with the tool. You could just set them up by default. So let's visualize n now, and our n in here. So by default, the forward direction in the orientation tab is along the Z. You could actually change some stuff. You could see that this option exists, but it's not doing anything. It's because we're set to direction in the up method. If you switch it to normals, our forward vector is actually following surface. We're going to talk about all of this in a separate session. I just wanted to mention that this is an option to follow the surface or just point towards a certain direction. But we're going to talk about this later. Doesn't matter right now. You can randomize it. You could also randomize it in the Z direction, but it doesn't work if you have this flow selected in here. We're just going to select this. If you want to flow along the surface, but if you don't want to, if you want to see something happening in the Z direction, that you should actually randomize your up. So this is our forward, and we're gonna also visualize our up and randomize our up as well. So this is what you get. And if you uncheck this visualizer and switch back to your objects, you can actually see that everything is just randomly distributed in our scene, which is exactly what we wanted. So let's just bring them back. This is what we had from by default. Everything is me uncheck two attributes in the way. Everything is following surface. Everything looks good. You could rotate them. You could randomize them. You could rotate and randomize them. You could randomize up. You could rotate up. So you get a bunch of different controls in here. I'm just going to bring everything back. And of course, for example, in this case, you could exclude a certain variant from this. So like we are rotating everything except variant number 0 now. You could also get similar thing in the direction selection tab. So you are now randomizing everything. But if you want some, essentially some stuff to be excluded from it, you could hit, for example, 0 in here, and this one would the only one that's being rotated. It doesn't work with exclusion. It actually works with selection. So you are selecting something to be associated to be affected by the randomizer. Now we're going to talk about all of this in a separate video. So I'm just going to set everything to be default one. There's actually other options in here. We're just going to ignore that for the time being. I'm trying to keep this video pretty fast. I don't want to go over everything in just one video. It's not going to be easy to just cover everything. So you have your geometry. You could go to the geometry tab to do some basic stuff. For example, sit on the surface. Everything will sit on the surface. I talked about the mask section. We're just going to push it a little bit more. Now here's the thing. If you go to the post-process tab, you have this post-process relax. And you could push it, and as you can see, we're sort of detecting collision and avoiding collision. There might be issues from time to time. Obviously, it's not perfect, but it is doing its best. So one thing that just comes to mind right now, if we visualize our density, and the tool might break in here. It's a known bug. When you're visualizing density and playing with the tool, sometimes it freaks out, exactly as what happened right now. So let me pause and relaunch Houdini, and we'll talk about it. Okay, so Houdini is back on. Again, I am going to visualize density because I do want to see it, but again, be aware, sometimes it freaks out. It's because it doesn't like it to be visualizing this, and this attribute doesn't exist in here, so it's going to freak out. It doesn't really matter. You could also just kind of go in here, visualize your surface attribute. For example, put surface. By default, it will show you the object mask. You could just visualize density. It's actually the same in here, I think. Yeah. Oh, it's actually showing density. I don't think it was showing the object mask. So if I, yeah, this is the object. Okay, but we are working with density. So this is your density, and then just turning it off. This is your object. Now what's happening in here, I still need to show this by going to the merge. So we are relaxing them, but as you can see, it's just not following our density anymore because, well, we're relaxing it on the surface. So it's gonna try to avoid the Pscale attribute, essentially avoid collision. So it's just gonna bleed over here and it's gonna ignore the density. So the way you can fix it is with this density compensation. I'm just gonna come in here to avoid crashing again. And as you push this, you start to notice that things are being limited inside. And if you push it too far, it's going to look like this. Now all your objects are in just one spot. This is where density is bigger than 0.999. So it's going to be a very small section. But something like this should actually be pretty good. And if you visualize it now, you can see we are avoiding all the these parts where density is set to 0. I'm going to risk it and just push it once. Maybe not sliding will break it. I think sliding sometimes breaks it, but everything looks good now. So let's just leave it at this. We are avoiding this. And again, this area, even though we have density, we have an object mask. So everything is just avoiding this part entirely. And if you want to see like the correct density right now, go to visualizer, visualize, and this is the actual density because we have this mask. Okay, you could randomize the color. You could turn it off if you want. You could get like an advanced color section. So if you want to set up something specifically, you could use this interface. What else? You could generate ID. And now we have an ID attribute. You could calculate the rest. If you have, if you're not packing everything, I would recommend working with packed objects. If you need stuff to be not packed, just set this to convert initial pack to geo, and now you have your rest attribute, which you could visualize in here. This is a world-based rest attribute. If you don't want to see it like this, just set it up on each one, and now it will be transferred. Right now we don't have it, so it's just kind of trying to calculate it, but that doesn't exist obviously. Could pack them up if you don't have packed geo in here. So if, for example, you have just like a merge node, you could pack them internally. I'm just gonna ignore this one, and we are bringing objects. As you can see, the results are the same. If you hit this one, it's just gonna freak out because putting everything on top of each other. But if you just have a merge sub there, you're not using packed objects, you could pack an instance. And as you can see, the results are literally the same, but I would recommend just bringing in packed geometry because it's just a better workflow for the tool. And let me just, I'm just gonna go back to what we had because, okay. And that's pretty much it for the intro tutorial. We have group variants, which will allow us to work with the groups in here. So you could wire these into like a solver, use them to separate things. If you haven't set up material in here, you could use it. What else can I just quickly talk about? Let's just talk about this one, but this is the last thing we're going to talk about in this tutorial. So we have multiply Pscale. And if you check this one, by default, nothing happens. We're working with variant. Ignore this type attribute and both. The type attribute is a separate attribute that you can set up, but we're going to talk about it in the second tutorial. But let's just focus on variant. You can multiply the Pscale based on the variant. You could set up whatever amount you want in here. So you have like 3 different lists. Let's say 2 different lists because it's easier. We want to influence the variant number 0. And we want to influence the variant number 2 and 3. But how can we know these numbers? Well, you go to Visualizer tab, show me the variants, and you can actually see the variant numbers associated with each object. If you don't like this look, just hit show me the locations. And now, as you can see, the tool is changing the output. Obviously we have a box in here, so it's a little bit, might not be too visible, but as you can see, everything is just turning into a box and it's preserving the volume. So there's like a bound object around it. This becomes much more visible if you have something like Tommy. coming in here, wire to this merge packed, and as you can see, everything is just turning into a box. Everything is carrying their variant number on them. It's following the order in here, so the order matters: 0, 1, 2, 3, and 4. So exactly what you're seeing in here. And this is an easy way of working with things. And there's a freeze frame, so if you have animation on it, you're just freezing it on first frame or on any frame that you want that shows you more information. And this way, everything will be much faster, even if your input is quite complex. And now that we know this location, we know which one we're working with, we could go to the point section, we could go to the Pscale and just start making them bigger or smaller. As you can see, since we have we are working with the relax section, it is also relaxing it, so things are moving around. If you don't want that, just turn it back to 0 and tool will ignore them. So you can make them bigger or smaller. I want smaller stuff for variant number 0, and I want bigger stuff for, let's say, 3 and 4, because we just for the Tommy. So as you can see, we are making 3 and 4 much bigger. And when you're satisfied, you could just go to the visualizer tab and just turn it off. Or for simpler stuff, you just work with them. It's fine. And I'm also gonna relax them as well. So let's just as a recap, let's go to orientation section. I'm gonna randomize my forward, which makes it so they are rotating around their axis. So it's not rotating them in the Z direction. Even if I play with this, I am randomizing them, but it's not really getting anything because we are projecting that normals onto the surface. You could uncheck this flow and now just randomize everything on every direction. But now, even if you set it to 0, it's not correctly following the normal. I would recommend using this flow object whenever you can, because it's a cool section. As you can see, like without this flow along surface, everything is kind of breaking, it's not following. But if you set this, everything looks perfect, everything is following this, and you could still randomize forward. You're just not getting it in the Z direction. This is the amount that the Z is causing, because again, we're projecting. But that's where you could randomize up and start to get more interesting shapes. And again, you could also just randomize in every direction. So just things are just going nuts, or just randomize it along Y, or maybe even switch it to direction. And direction, the way direction works is if we just bring everything down, everything now in the certain direction. Let me actually just remove this texture. And as you can see, it's not updating. So you need to just click somewhere else and come back, and now it is updating. Since they are packed geometry, this is just a viewport bug. It's not really. And now you could, again, randomize rotation in here, randomize up. With this method, the flow along surface is not doing anything because our up vector is just literally pointing up. It's not flowing along the normals. So the axis for forward will also not be flowing along the surface. And you could rotate them around their axis. These axes, they shouldn't be the same. So if I set this to 0 and set this to 1, we're not going to see any actually I'm working with the wrong one. I'm not going to see any rotations if these two axes are the same, because obviously there's no rotation when it's the same. It's also true about the up vector as well. So right now direction is set to world Y, but if I come here to the rotation axis and also set it to world Y, now I'm not seeing anything. But if I uncheck this one, go to the first one, should be on the normals actually, to see something in here. And you are rotating things, as you can see. It's not perfect. As you can see, there's like a coming back thing, but it is working. It is rotating them around, and the perfect one comes from rotation axis Z. So rotating them around, and that's also true for direction. You could also do this in here. This is actually blend. You could rotate this in here, which is kind of interesting. I should actually set this to be on just Z by default, because it is a nicer rotation. I'm gonna do it next. But yeah, this is what we get. Just right out the box from the tool. Very simple stuff. Sticking to the surface, going around, going crazy. You could do really nice things. And oh, before I forget, there's just one more thing that I want to talk about. Sometimes in your workflow, you are actually designing the points yourself, so you have a specific look that you want. It's totally possible. You don't need to just rely on the scatter node inside this tool. You could just place the scatters up, scatter them the way you want, exactly the way you want. The only downside is that, first of all, you need to be carrying a couple of attributes. So I'm going to add normals to my surface. And I also need Pscale, because Pscale is being generated internally. And if you're avoiding that, you do need to set it up in here. Just bring it to something pretty low, maybe like this. And now we're not seeing anything because we are generating the points internally. If I uncheck this one, we are actually seeing everything, and everything is working again. Orientation might be weird. It depends on what you're setting up. If you don't have this, by default, it will use up vector as world Y, I believe, even if you are working with the normals. And this one is also just not really doing anything because we are just pointing towards the direction, and our normal will be set to up to world Y by default. See, just like no difference. If we enable it, we are getting something. The tool is freaking out a little bit. I'm just gonna bring this down because I don't want that. This post-processing is not gonna be perfect because we are working with points now, and there's just essentially nothing to compensate for in here. So just setting it to 0. If you are working like this, and again, when we play the animation, it's gonna freak out. So you're gonna interpolate. So just like enable these two options, put down interpolate internally. That's also what's happening in here. Just as you can see, the inside of the tool is just crazy. So I would encourage you to actually jump inside, but don't focus too much on what's happening. For example, in this section, these are more advanced stuff. We're going to talk about it in another video. Also, this whole section in here, this is just for the curves. We have a separate input for them if you want. Like, you can use them in the first one, but this is like a preset for creating vegetation. We're going to talk about it later. These are our essentially detailed stuff. So this one's the bounds and the numbers, and this one is just the show me the variance section where you could actually see what's happening. So yeah, this is just a quick overview. Just go to the gumroad page, download this toolset, play with it, see if you like it. If you do, please consider donating to the page because it will help me out quite a lot. I'm going to switch this one to the original one because I prefer just generating them internally. But if you are working with, for example, let's say a PopNet, you do want to just uncheck this because you want to use the input, and also go to the scatter section and turn this off. This is only for surfaces because you want them to stick. If you are putting points in here, you don't want this to stick to anything. You are working with floating points, so, and your points are being generated as you go with the PopNet. So you don't want them to stick to anything because otherwise it's just going to freeze at first frame and you're just going to see one point just standing in the air. But yeah, that's pretty much it. I hope you guys like this one. Please just work with it. Share your projects with me. If you have any questions, you can find me on Discord. You can find me on Instagram. You can find me on Twitter. You can email me. I'm always just available. So please don't hesitate to ask any questions. I will be uploading more tutorials. I will be uploading more complex setups. We will actually be creating one of these setups from the teaser. Not all of them, but we are gonna create one of these. So you could actually write in the comment section which one do you want to see. You want to see the shelf, which by the way is actually the same thing from the tool itself. If you look in here, you actually have this icon. As I mentioned, my girlfriend designed this one for me, and I decided to actually create the scene. Whichever you guys pick, we're gonna just create that particular scene. As you can see, the tool is compatible with Vellum. The tool is compatible with RBD stuff. Very loud music. Tool is pretty compatible with anything. At least I haven't been able to find any errors. And before I close it, one tiny little thing. And if you wire anything related to MOPS, so MOPS, let's say MOPS transform modifier, everything works. So you could just scatter them normally, everything pointing up, and just use MOPS fall-offs, MOPS modifiers. Everything works in here because internally this is just a packed object being calculated. And generate ID would work very well for you. If you're getting weird issues with MOPS, just hit generate ID and you have an ID associated with everything. I don't think I can actually visualize it right now. I don't know why, but there is an ID attribute sitting on everything. Maybe it's the color section, or maybe let me go to post visualizer and just uncheck this one. For some reason I'm not seeing it, but there is ID associated with everything right now, and everything is working correctly, so don't worry about that. I don't know why it's not visible, but MOPS will recognize them and it will be transferred down below, and you could just use fall off modifier in the example file that you guys have from the Gumroad page. You could actually there's a very simple setup for MOPS, just so you guys know how to work with it. I don't know, like, let's do the fall off, and there you go. So everything is if I push them more, the white section, so everything will, as you can see, maybe it will be easier to actually remap this that way. There we go. So, and also maybe just stop this from around. I don't want to see this preview. So yeah, as you can see, things are following this. And you could, I don't know, set the from scale to be 0 and then just set to be 1. I don't know, some like basic stuff. This is weird, but yeah, like you could do a bunch of different things in here. Just play with it, see what you like. If you're an advanced MOPS user, you're gonna love this because you have your variants in here. Everything is packed, everything is fast. And if you're an advanced Redshift user, you also have access to Redshift proxies. We're going to talk about this. This is a full session. It's a very cool thing. I actually picked this one up from Rich Nosworthy, as I mentioned. So we are working with the same setup as he has. I've just kind of like separated it into different sections. And that's it, guys. Thanks for watching this video and take care. Let me know what you think about the tool. Cheers.